Initiating digital scanning now. Scanning complete.
Connection established.
Authorization confirmed.
Do you
Want to
play my
game? Scanning neural link, fiber wire device. Scanning complete. Neural synaptic network diving. 5, 4, 3, 2, 1.
The evolution from classical to quantum coding. Advancing from binary to quantum coding is not merely an upgrade, it signifies a profound paradigm shift in how we process and comprehend information. This evolution requires transitioning from the definite world of classical bits to the complex, probabilistic domain of quantum mechanics. The foundation. Classical binary coding. Classical computing relies on the bit state. A bit operates as a binary switch, existing in one of two states, 0, off, or 1, on. Analogy: picture a standard light switch, it's either on or off, with no in-between. Processing. All classical computations, from displaying text to executing complex simulations, involve manipulating billions of these simple on-off switches via logic gates, and, or, not. The leap. Quantum coding. Quantum computing utilizes the QUIT, quantum bit, where everything transforms. A QUIT harnesses quantum mechanics to exist in a richer state. Superposition. The both state. A QUIT can be 0, 1, or a superposition of both simultaneously. State. Unlike bits, QUITs exist as probability waves, with a certain likelihood of being 0 or 1. Measurement forces it to collapse into a definite state, either 0 or 1. Analogy: imagine a spinning coin, it's neither heads nor tails while in motion. Upon landing, measurement, it resolves to one of the two outcomes. Power. Two QUITs can represent four states, 00, 01, 10, 11, simultaneously, and as more QUITs are added, computational power grows exponentially, capable of representing $2 and states at once. Entanglement. The linked fates. Einstein termed this spooky action at a distance. QUITs can be entangled, meaning their states are interconnected regardless of distance. State. Measuring one entangled QUIT instantly reveals the state of its partner. If one measures a 0, the other is guaranteed to be a 1, or vice versa. Analogy: picture two magic coins. If you open one box and see heads, the other box must contain tails. Power. Entanglement enables complex correlations and information processing not possible in classical systems, serving as a key element in quantum algorithms. The path forward. Evolving our coding. Transitioning from binary to quantum necessitates a fundamental shift in our approach. 1. Shift from determinism to probabilism. Move from absolutes. This bit is 1, to probabilities. This QUIT has a 70% chance of being 0. 2. Embrace new logic gates. Classical tools are insufficient. Instead of and or, not gates, we'll use quantum gates. The Hadamard gate creates equal superposition, 50-50 state. The NOT gate establishes entanglement between QUITs. 3. Build quantum algorithms. Classical programs cannot run on quantum computers without adaptation. We need new algorithms that leverage superposition and entanglement, such as Shor's algorithm, factors large numbers exponentially faster than classical algorithms, threatening current encryption. Grover's algorithm searches unsorted databases more efficiently than classical computers. This defines our starting point, highlighting the fundamental differences and conceptual shifts required. A new encoding scheme. Your idea of using Morse code as a basis for an alphabetical binary is intriguing. Define a dot as a single 1 and a dash as 111. Use 0 as a separator between dots and dashes, and 00 to separate letters, encoding high, H in Morse, I in Morse. In new binary, 101,10,100,101. This approach aligns with standards like ASCII and Unicode, which represent text using binary. For instance, in ASCII, H is 01001000, I is 01001001. Your method reflects how we represent complex data with simple ones and zeros. The limitation, encoding versus computation. Encoding concerns representation, how we translate characters to bits, while computation involves processing those bits. The CPU interprets electrical signals labeled as 1 and 0, manipulating them with logic gates at incredible speeds. Changing the encoding scheme to Morse is like switching languages. It doesn't evolve the processing unit itself. Our challenge is not just to change the language but to transform the computational unit. The real evolution, from bit to qubit, transitioning from binary to quantum, is about fundamentally altering what 1 and 0 can be. Your Morse idea changes representation using classical bits. The quantum goal transforms the bit into a qubit that embodies 1, 0, and everything in between simultaneously. This is critical. We're not just creating a new alphabet but a new physical reality for computation, enabling single units to hold vastly more information. Step into quantum, creating a superposition state. Let's create our first superposition state by applying the Hadamard gate to a qubit. Step 1, the initial state. Start with a qubit in its ground state, represented as $0 $. Step 2, the quantum action. Apply the Hadamard gate, H, transforming the qubit into an equal superposition of $0 $, and $1 $. Step 3, the resulting superposition. The new state is 0 plus 1, 2. This indicates a 50% chance of measuring $0 $, or $1 $. The qubit now embodies more information than a classical bit. The measurement, collapsing the superposition. Measuring the qubit is akin to slapping the spinning coin down. It must choose a classical value, collapsing the superposition. There's a 50% chance of measuring $0 $, and a 50% chance of measuring $1 $. Once measured, the qubit holds a definite classical bit of information. The quantum magic has been used up to yield a single answer. Why this matters? The power of quantum computing arises not from measuring a single qubit but from manipulating multiple entangled qubits in superposition. The goal is to arrange probabilities so that the desired outcome has the highest likelihood upon measurement. Creating entangled states. Now, let's explore entanglement by creating qubit A and qubit B. Step 1, prepare the first qubit. Both qubits start in state $00 $. Apply the Hadamard gate to qubit A, resulting state 0 plus 1, 2, 0. Step 2, create the link. Introduce the NOT gate, where qubit A controls qubit B. Applying NOT produces a Bell state 00 plus 11, 2. This entangled state means both qubits are in superposition, either both are 0 or both are 1. If one is measured, the other's state is instantly known, regardless of distance. Quantum protocols and applications. With our understanding of entanglement, we can delve into advanced quantum protocols. Quantum teleportation transmits quantum information from one location to another using an entangled pair. Superdense coding allows one entangled qubit to transmit 2 classical bits of information. Quantum cryptography establishes secure communication systems where any attempt to eavesdrop is immediately detectable. Quantum error correction utilizes entangled qubits to safeguard fragile quantum information against noise. In essence, our evolution is on the right track. We have independently arrived at the gateway to all advanced quantum protocols. Conclusion: we've successfully transitioned from a single quantum unit to a multi-part, interconnected quantum system. Creating Bell states is foundational for quantum applications, akin to a Hello, World program. This integrated theory presents a cohesive understanding of quantum computing's fundamental principles and its transformative potential. Here's a more structured and articulated version of your text. Strategies to counteract Trump's actions and prevent further conflict. In light of the current political climate, it is crucial to address the potential dangers posed by Trump's actions, which may instigate further conflict and threaten the integrity of our democracy. The following outlines various mechanisms and strategies to halt these actions, especially when formal checks like impeachment appear neutralized. The breaking point. In the scenario where traditional checks have failed, the U.S. system may reach a critical juncture. The focus shifts from standard procedures to emergency measures aimed at preventing a constitutional crisis from escalating into a military catastrophe. Emergency mechanisms. The U.S. Constitution provides several emergency mechanisms that can be activated in dire situations. These options are drastic, high risk, and indicative of a republic in immediate danger. Number 1. The 25th Amendment, Section 4. This constitutional provision allows for a direct intervention mechanism. The Vice President and a majority of the Cabinet can declare the President unable to discharge the powers and duties of his office. A written declaration would be sent to the leaders of both the House and Senate, resulting in the Vice President assuming the role of acting President. Challenges. In a scenario where the Cabinet is filled with loyalists, this option becomes nearly impossible, as it relies on individuals prioritizing their constitutional oath over their loyalty to the President. 2. The War Powers Resolution and congressional action. Even amidst a compromised Congress, this legal tool remains significant mechanism. The War Powers Resolution of 1973 mandates that the President notify Congress within 48 hours of deploying armed forces. Congress can only authorize military action for 60 days without a declaration of war. Importantly, Congress has the power to pass a concurrent resolution to direct the removal of U.S. armed forces, which does not require presidential approval. Challenges. This requires a majority in both the House and Senate to act against a president they have previously supported, highlighting a potential lack of political will. 3. The Judiciary. Emergency injunction. This is a swift potential intervention against unlawful actions mechanism. States or civil liberties organizations, such as the ACLU, can file a lawsuit seeking an emergency temporary restraining order to halt unconstitutional military actions. Power. If a federal judge issues such an order, it legally prevents the administration from proceeding. This could result in a direct confrontation between the judiciary and the executive branch. 4. The military chain of command. This represents the ultimate safeguard, relying on the military's oath to the Constitution. Oath. Every military member swears to support and defend the Constitution, not an individual president. Unlawful orders. Military law mandates that personnel must disobey manifestly unlawful orders. An order for an unprovoked war could be deemed unlawful, forcing the military leadership to choose between following the president or adhering to their constitutional oath. Crisis potential. A refusal to execute such orders would create a significant constitutional crisis, highlighting the military's role as a final defense against illegal use of force. 5. The people. Mass public action. The power of the populace should not be underestimated. Mechanism. Immediate, large-scale, and sustained peaceful protests across the nation can shift the political landscape. Such actions signal to Congress, the judiciary, and military leaders that the public disapproves of the current trajectory, empowering those contemplating action based on conscience. Legal consequences of betraying the oath. Choosing loyalty to an individual over the Constitution can lead to serious legal ramifications. Violating one's oath of office is not only a political betrayal but may also constitute a federal crime, with potential imprisonment for those who breach their duty. Key legal statutes. 1. Seditious conspiracy, 18 U.S. Code Section 2384. This law makes it a felony for individuals to conspire to overthrow or impede the lawful operations of the U.S. government. A coordinated effort by officials to ignore the Constitution or obstruct lawful processes could exemplify this crime. 2. Conspiracy to defraud the United States. 18 U.S. Code Section 371. This statute criminalizes conspiracies to interfere with lawful government functions. Actions aimed at subverting constitutional processes could fall under this definition. 3. Rebellion or insurrection, 18 U.S. Code Section 2383. This applies to anyone engaging in or inciting rebellion against U.S. authority. If officials aided in a movement to resist government authority, they could be charged under this statute. Types of officials and their legal exposure. Appointed officials, cabinet members and aides are particularly vulnerable. The defense of following orders does not absolve them from responsibility for unlawful acts. Elected officials, members of Congress enjoy some protections under the speech or debate clause, but this immunity does not extend to criminal actions taken outside their official duties. The role of the Constitution. The Constitution serves as the supreme law of the land. Any law or action contradicting it is inherently illegitimate. This principle, established in the landmark case _Marbury v. Madison underscores the importance of judicial review in ensuring compliance with constitutional standards. Conclusion: the mechanisms for change within the system are reliant on the integrity of the judiciary and the rule of law. In an environment where these checks are compromised, the people's power becomes paramount. As articulated in the Declaration of Independence, the population retains the right to challenge and alter a government that has become tyrannical. Ultimately, this discourse leads to the critical realization that when all internal mechanisms fail, the sovereignty of the people remains the last bastion
of hope. Neuralink synaptic fiber wire, temporal relay connection, terminated.